You haven't heard my speech yet, so you may want to hold off a little bit. Okay, you probably all read it. Hello. It's my name. That's what I do. I work for Sky. Sky's tagline is believe in better. And I don't normally drag out a corporate sort of tagline, especially in front of a technical audience. But it's interesting because this whole sort of process that I'm going to walk you through started because of this. Believing in better is like sort of believing in Santa Claus. It doesn't make it true. You actually have to action that belief. And Sky has done that. And in fact, one of the things that led to the cloud was Sky is an agile environment, and they empower their teams. Now, an empowered team is an absolutely fantastic thing. They're empowered to do stuff. They're empowered to do it right. The biggest problem with that whole empowerment is that they are empowered. So, and I'll give you a quick example. So there was an email or a blog post or something. I read it anyhow, and it was an interesting article on new and upcoming language, Go. So I read it, I thought, yeah, that's interesting. Went onto the website, had to play around with it, thought, yeah, that's not too bad. The next day, I kid you not, the next day, when I was at my desk at 9 a.m, there was an email from one of the Scrum teams that says, can we deploy Go so we can use this? So they were empowered. They had no use case. They had absolutely no business reason. They just wanted to test it out. And that's a fantastic thing. However, obviously, it puts a lot of pressure on the poor DevOps people who have to sort of roll this out for them. I want to say thanks to The Guardian for hosting this meetup, especially to Simon and Stuart, who gave me the honour and the pleasure to actually come and speak before you today. I hope I won't let them down. And for the excellent pizza, and I will be drinking heavily after I've finished this. So, Cloudfoundry from 0 to V1 to V2 to hopefully Hero. Hopefully I will be one of the heroes that gets to deliver this. So I'm just going to walk you through a bit of history of how we got to this place. Excuse me. So, that's going back probably a while. You're probably all cutting edge, and this is probably an old thing. So N tier, when N equals 3. So you'd have your web server, VM, you'd have your application tier, and you have your data tier. 3 VMs. Plus, we'd have a leg A and leg B. Oh, we've also got disaster recovery. So we'd need 12 VMs just for a simple N-tier architecture for any sort of website. This is for a very small one. Obviously, that would scale as we needed more web and app tiers. Plus, you needed staging. And, of course, dev, which is 6 to 20 VMs, depending on what they're going to do. So you're looking at 42 to 56 VMs in total, 80 gigs of RAM, and I just made that up. I have no idea how much we allocate to each of them. 500 gig of storage, 1 or 2 big numbers here. So it's an obvious thing with resource utilization here. Our largest VM-wise application is 96 VMs. That's one of our largest ones. That's not including our dev environments, and they have about 30 of those, of which at any one time 12 are actively serving traffic. So out of 96, we have 12 actively serving traffic. All our Scrum teams wanted a web page, easily, quickly. So if we want to set up a new, similar sort of site, which is a content management site, we need to spin up 96 VMs, we need to get all the resources. Incredibly difficult, incredibly complex. And not only that, what happens is, obviously, we don't have those sort of resources available in an instant. We get to order hardware, we get to go through approval processes, all that sort of thing, and it can take a long time. And there's a lovely picture of the Sky web page. That's not actually the web page that consumes 96 VMs. This is one of the nice ones that runs on Cloudfoundry. Oop, right. So from that sort of starting point where we're all virtualized, we decided to go to V1 of some sort of PaaS offering. So we're going to run pretty much on our VMs. We'll just spin up new VMs, run a PaaS on top of that. So we looked at Staccato, and I must say that I did very, very little of this, but I'm going to take a little bit of the credit for it anyhow by talking to you about it. But it was actually the DevOps team. So that was in November 2011. For those who don't know, Staccato is sort of like a commercial-ish Cloudfoundry offering. They built some goodness on top of it. We did a Cloudfoundry spike. Cloudfoundry is open source. You can get their code on GitHub. That was in December. We forked Cloudfoundry, and we munged it into our build system. So this is sort of, we got the Cloudfoundry code about 2.5 years ago now, and we munged it in, and hey presto, we had a cloud. This cloud has been incredibly successful. In production, we've got 255 apps and 554 instances. I'm not sure whether you know much. I'll go more into sort of, if you don't know what Cloudfoundry and how it works, in a later slide. Staging about the same. We like to keep it in sync. The interesting one is this development. So we have 485 apps, low number of instances, but a lot of apps. So 485 different number of apps. Now, this is what our Scrum teams would do. They would spin up a simple app because it will take you literally, once you've written the code, which can take them weeks and months and years, it will take you seconds, if not minutes, to actually spin up a new app and have it live. It is absolutely fantastic. So that's what they've done. Obviously, they don't clean up after themselves, as Scrum teams never do. So they've left a lot of them running, and we eventually just go around and kill them. The app's not the Scrum teams. In production, 80 to 100 are live at any one time. So it's been incredibly successful. This is in 2.5 years from 0 to version 1 of Cloudfoundry. We've got some of our very prominent, very large websites on it. Some notable features. I'll just sort of... So container firewalls, user configurable web proxy. You can read all these sort of things. The one, obviously content caching. If they pass through the right headers, we will cache the content for them. They don't like passing through the right headers. It's far too difficult for them. But nevertheless, we've added the internal external routing of apps. Excuse me. And of course, lots of bug fixes. So the internal external routing of apps, I wanted to sort of highlight. So in a normal Cloudfoundry instance, you would have a domain that is presented, and then you would have subdomains or other domains that would point to this, and it's available externally to everybody in the internet. Obviously at Sky, we like to keep a few things under wraps. We like to do some internal development work. So we actually added an internal routing layer to that, which is only available to our corporate network. This was incredibly important for us, and it was very successful as well. People would run stuff up, didn't have to go anywhere. It was secured within our environment, and then we could send it off to all the marketing people or the sales or whoever wanted to see it. They could have a look at it, they could test it, QA it, and then very simply, we could actually make that live within seconds, and it would go live to the internet and to the world. This was one feature which has actually served us incredibly well over the time. Some notable apps. www.sky.com, our homepage, runs on this. Assets.sky.com. You'll have to excuse me. So every single one, well, not every single, but most of the websites that we run, and we run quite a number, and this is not just within the area that I work, which is in software engineering, sales and service. There are other sort of news and marketing and all sorts of other departments. This holds our CSS, our media assets, all that sort of thing. So it gets quite a bit of hits. Once they actually added some caching, we got a lot less, which was good. mysky.sky.com. So this is where, as a Sky customer, as I hope you all are, it's a fantastic offering. No, actually, I'm not doing a sales pitch. That's where, as a customer, you can go in and you can check what you've got, what your bill is, that sort of thing. Thank you. Buy.sky.com does what it says on the tin. Broadbandshield.sky.com. So we have a website filtering. This is getting about 4 million hits a day. Yeah, not too much. They're looking to scale it up to over a couple of 100 million. So this is very important for us. I just wanted to show you a few of the apps. So we've got some brochureware, we've got some interactive sites, we've got some important customer-facing sites. As I said, somewhere in the range of 80 to 100. We're never quite sure how many apps are live. Well, we can tell you at any one instance in time, but we can't tell you sort of from a day-to-day basis. So where to now? Cloudfoundry Redux. So V2 is the hero. And it's a hero for a number of reasons, which I will go into. We want to learn from the V1 deployment, solve some of the inherent problems with the model. And I apologise for reading the same slide that you were seeing. There were a lot of problems with our V1 model, which I will go through. And it's one of these things where you do your best effort, and whenever you're building something, you always think that you are building the best thing possible. And then obviously a request comes in, you've got to get it done by tomorrow, you just hack it in, I'll fix that later. And eventually it gets into the state where it works, and it's great, but it's not the best system. So what are the problems? A legacy build system, high availability, disaster recovery, keeping in sync with Cloudfoundry, so the actual open source Cloudfoundry code, and resource utilization. So our legacy build system and custom in-house build and deployment system, very, very common throughout the industry. Well, ours isn't, but I assume a lot of people have their custom build things. It has served us well for 6 years. We've deployed 2,000 VMs. We've got, I don't know, 1,100 apps in total on a cloud. It does all of this. It is absolutely fantastic. It is starting to creak around the edges. So it's time to standardize. So our solution, Bosch. Bosch is the premier way of deploying Cloudfoundry version 2. It is also the only way to deploy it. So I know that there is a flaw in my logic somewhere there. So as a part of that, we're also using Puppet. It's not that Bosch just can't do everything that we need it to do. It's not quite there yet. It is good for deploying Cloudfoundry version 2. If anybody is looking at Cloudfoundry v2 and they're looking at Bosch as a deployment tool, the one simple test I would ask you to do is just install a new cron script which sends an email every hour. Do that as a test when you're evaluating Bosch, see how simple it is, and make up your minds. High availability and disaster recovery. Inelegant solution. I think that's a lovely, my manager John Fred suggested that. I think it's a lovely, lovely term for our high availability DR. It is functional, but it is painful to operate and manage. And this is something that we sort of bolted on at some point in time. It's not actively tested. Some of it is, some of it isn't. And there's no real Scrum team responsibility. It's all DevOps. We have to do it. We're up at 3 a.m. in the morning doing this stuff. Maybe one of them is awake and they press a button and say, yeah, it's live. But we're doing most of the stuff behind the scene. So the solution to that is very simple. We're going to build it in from the start. We're going to go dual data center. We're not doing single data centers anymore. Dual data center, high availability, disaster recovery. It's unfortunate that Cloudfoundry v2 is not quite dual data center aware. It's not dual data center aware. It's not even close to not quite. It's just not. So that's something that we are building in. Keeping in sync with Cloudfoundry. We forked Cloudfoundry version 1 2 years ago, 2 and a bit maybe. We munged it into our build system, our glorious build system, which gave us this beautiful cloud which people loved. And on a daily basis, they thank us for it. You know how polite Scrum teams can be. We never merged back from the master. So we just forked it and it still works. It's great. The solution, we're now fortnightly merging back for our version 2. We want to keep closer. We have this premonition or fear or something that eventually what will happen is we'll actually get to a point where we've veered so far away from the code that we can no longer merge back the changes. Resource utilization. We are running out of space. The cloud will solve all of our problems. It is a silver bullet. The problem with the cloud is that because people can spin up apps so quickly, they will, and we will run out of space even quicker. So we are building in resource monitoring, and we're making sure that when we get to a specified level, we'll hopefully be in a position to expand our estate. It's expensive to add new capacity, both compute and storage. It's a slow route to production, and human resources as well. We want to step away from actually doing any work. Well, actually, that is sort of, we're going from this DevOps term to this NoOps. We want to give the power to the Scrum teams to actually do whatever they want, and we will just provide the plumbing underneath and let them deploy their apps with their languages and whatever they want to do. So the solution is the application containers, not VMs. We will still have to provide some virtual machines and look after them. However, we're trying to reduce that. We're trying to get everyone to move over to the cloud. How are we going to do this? That is a mighty fine question. So Cloudfoundry v2 went live approximately last year, June. They completely obliterated v1. You cannot find version 1 code anywhere. If you have it, it's rarer than hen's teeth. You should sell it. One of our teams is using V1. They have to use the Internet Archive, the Wayback Machine, to actually see the documentation for version 1. So despite the open source nature of it, and it's going to last forever, it's gone. We have new data centers. Bright, shiny, new data centers, new equipment, fantastic. DevOps playgrounds. We forked the vSource code. We have open sourced this. We want to give back to the open source community. Pivotal sees Sky as one of the top 5 people contributing back to Cloudfoundry. That's one of 2 things. Either there aren't many people doing it, or we really are damn good at what we do. I'd like to think it's the latter rather than the former. We have had code changes merged back. There are subtle differences between the direction that Cloudfoundry wants to go and the direction that Sky needs to go as a corporate entity. So not all changes will be merged back. And we're going to go active-active setup. There's no more active-passive. And throughout this presentation, I will lie to you subtly on a couple of points to make the story seem better. There will be a few active-passive, but we're going to beat the Scrum teams into submission to make sure that they are testing that on a weekly basis. So what do we get? We get to concentrate on enabling the teams. These empowered teams, we get to give them better stuff, faster. Once we deliver Redis for one of our teams, we have delivered for all of the teams. They all get to use it and consume it, rather than having to spin up a VM for this Redis and that Redis and making sure it connects to whatever their app is. More DevOps, less application support. I don't know if anyone has used Heroku or how Heroku works. If you try to get support out of Heroku, your first thing really is to Google it. Maybe you'll raise a support ticket, but you're not going to get much love. We would like the Scrum team to start helping themselves. We, of course, are always there to support them, but we want them to start helping themselves. They will often come to us and say, my app didn't start up. Did you look at the logs? How do I do that? Did you read the wiki? Where is it? So all of these sort of things. We want to make it, with the new Cloudfoundry version 2, they provide the application code, and most importantly, or more importantly, they also provide the runtime. So you have now Heroku build packs are compatible with Cloudfoundry. I could be lying to you on that, but I know that there are some Heroku build packs which are compatible with Cloudfoundry. If they want to do something in Go and they want to do it tomorrow, they can get that build pack, they can write it in Go, and they can deploy it themselves. We don't have to touch it. That is the power that Cloudfoundry V2 will give us. More fun? We have lots of fun at Sky. What do the Scrum teams get? They get greater control, but greater responsibility. They get to control their scalability issues. If they've got the World Cup is starting tomorrow, I believe. I was corrected. I'm not a big football fan, so please forgive me. If there is going to be a big promotion or a big game and they need to scale it up, they get to do it. They can scale their application instances instantly. Well, it takes seconds for them to do that. Quicker route to market, that makes everybody happy. That means that you can iterate quicker. It means that you can get something out, send it around. People like it, don't like it. We can push it live, make it much quicker. And we get to deliver them a greater range of back-end services, which gives those services to everybody, not just a specific team. So what's next? Deploy V2. Save for production, go ready end of September. We've got a V2 deployment running on dual data centers as we speak. Maybe not as we speak, because we just upgraded to version 1.7 or build 172, so it might still be down, but we do have V2 running. Build a community. We want to get the Scrum teams more involved, more sort of DevOpsy, more care about what they're doing rather than throwing an application at some virtual machines and hoping that DevOps will look after it and cuddle it for them. Build, test, deploy, deploy, deploy. That's what they get to do. How Cloudfoundry works. I hope I did time this. I generally speak faster in front of people than when I time it myself, so hopefully I'm not running over time. So, the internet, obviously firewalls, that sort of stuff. So how it actually works, as you can see, we've got the external network and the internal network, and we've split those so we can have available to the internet or not. So what happens is you have a production application, and it is 4 instances, nice little This is currently live, and so we've mapped it to the domain www.sky.com. When we want to push a new version, when I say we, when the Scrum team wants to push a new version, they will push their new version, another 4 apps, and they will map this to an internal-only URL. So that means it might be www.internal.sky.com or whatever it is. They will then send it around, it'll be tested, QA'd, NFT'd, all the stuff that they want to do. Once they are ready, they will then, with a command, say, map these 4 instances to www.sky.com, unmap those 4 instances, and that's it. They're live, they've cut over. Cloudfoundry does all of the good work. Should there be a spelling mistake or something wrong, they just reverse that process and they can roll back within seconds as well. So it becomes a very powerful tool for them. That's just in case the demo fails. So I think, demo, right. That's assuming that I can actually see what I'm doing on this tiny, tiny screen. Right. So let's see if I can, VPN Security first. So this is a very quick demo app I wrote. Right, let's have a look. Okay, so I've quickly deployed what I'll do is I'll just do a CF. There's the first thing that you do is you tell it what API you want to talk to. You tell it what organisation, what space you want to be a part of. You then log in, and then you're ready to deploy. I skipped all those things because I get nervous under pressure. I might type in the wrong password too many times, and that would just be horrible. So what this is well, I think it's the interesting part. It may not interest everybody. What you can see is it's using this manifest file. So I actually got a manifest file to say what I'm going to push. I don't need to interact with the console in any single way. It says how many instances I want, how much memory I'm going to use. Then further down, it uploads the demo app from my WAR file. Downloads the app package, and this downloads the app build pack cache, which is a Java build pack here. It downloads the OpenJDK, downloads Tomcat, lifecycle support, blah, blah, blah. So what this is doing, it recognises automatically through some predefined rules. If it's got a webin folder, web XML file, it will actually say, okay, this is a Tomcat app. It'll get all these things from the build pack and it'll automatically do that for you. If you don't have a build pack, you can actually give it a build pack from anywhere on the internet and it will do that for you. And then it starts them up. As you can see at the end, there were 1 out of 4 running. And now there are 4 out of 4. Yeah. And there is an app live and ready. Now, obviously, I cheated a little bit. I'd already deployed it, and I meant to delete it, but I was in a rush. But that is that is pretty much. If I wanted to, I've already done the hello world. Okay. Just I think. Blah, 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 blah. Very tiny app. Normally what you do is you actually remap URLs. I'm just going to push it over the top just so it's just so it makes it a little bit quicker. Once again, it's going to upload, it's going to do the build pack, it's going to do the whatever it is. As you can see, it's all cached, which is nice. My apologies, there's nothing worse than watching a scrolling console. apart from probably hearing my Australian accent. And that's a very quick change that you can push very easily. So you can see on the iterative development cycle, it's very, very quick, assuming that you're bypassing QA or your unit tests and all that sort of stuff. And now I want to scale an app, and I cannot remember the command, which is typical. Nope. Okay. It's CF scale minus I6. Record. So I've just scaled that from 4 to 6. That's all I had to do. It automatically stages it, re-pushes it. Now I've got 6 apps, and that is the scalability of it. That is a mighty fine question, and I think, go back to here. Thanks and questions. That is, it doesn't. There are some auto-scaling algorithms out there. They are not quite ready, and it really does depend on what you're running as to how to scale it. Because you can blow up resources. What happens if you need 2,000 of these instances, and that's going to starve everybody else for resources? So, in a word, yes, but we're not using it. The man on this side. Yes. So Bosch is very good at what it does. It looks after all of the Cloudfoundry VMs. We're adding extra high availability into it because it doesn't quite provide it, but yes, there is. If one of the instances goes down, it'll automatically start it up. Yes, sir.
So, have you come across the issue whereby you have a sort of multi-tier system, your sort of service-based architecture? How are you dealing with the network in there? Or are you just letting everything talk to everything else?
Right. So no, we're not letting everyone talk to it. We have obviously we have containerized firewalls. If through a simple file you say what you want to talk to and when, and who you want to talk to, and that is it. If you say nothing, you can't talk to anything apart from the service that you've requested. If it's and it depends on the service, we may approve only certain URLs to allow certain apps. So we can, as a developer, you can say, I want to talk to all this stuff. And we may say as a DevOps, well, actually, that's a highly sensitive system. We're not going to allow you without the proper sign-off, that sort of thing.
And you've built that into your build process and your version, or is that sort of native?
So we've built it into Cloudfoundry, so it looks for this file, and then the Scrum teams have to provide this file to say, I want to talk to this. We run into problems when they want to talk to, say, Gmail, and it's got floating IPs, and it's got thousands of IPs, that sort of thing. But yeah, it's more the internal systems. Yes.
You've actually got a bunch of dedicated hardware that you can store for Cloudfoundry.
Right. So Cloudfoundry doesn't actually build the VMs. You need some. We have both. We've got just bare metal, which we've deployed some of the Cloudfoundry services on. This is on version 1, and some of them are virtual machines, which we've deployed other components. On version 2, we're using VMware, vSphere. So Bosch will automatically provision those VMs, which automatically spins up the Cloudfoundry components. So Cloudfoundry in itself could run on bare metal or virtual machines, but with Bosch, it certainly looks like it certainly prefers to have the VMs. It's got an AWS plugin, OpenStack plugin, vSphere plugin. Can be used for anything.
You could use as many machines as AWS could give you.
Yeah. Although generally so Bosch deploys the IaaS layer. So you would tell Bosch, I want 100 of these machines. So it would never spin up 20,000. And then on top of that, your cloud sits on top of that and spins up as many instances as the underlying virtual machines can give it. So.
One application experience that's consume one CPU, do you have any experience like this application is slow because there is a neighbor consuming all the resources and stuff like that?
No, if it goes above certain thresholds, it gets killed and restarted. So it's very good at killing stuff.
Let's talk about security. An application can talk with any other application inside of the cluster?
No. So an application can talk to itself, its data services that it's subscribed to, and obviously it can talk to other applications if it knows the URL that they are mapped to, but it doesn't share memory. It can't sort of do an inter-process communication.
This application can also call to the root of the Cloudfoundry and basically call any other application.
Yeah. So it could call another. So www.sky.com could call broadbandshield.sky.com just by going out and back in.
Do you recommend running internal services next to public services, or is it better to split having two instances, Cloudfoundry, one on the MZ and the other?
Well, we have a production Cloudfoundry, we have a staging Cloudfoundry, we have a dev. So production is in the DMZ, staging obviously is internal only, within limits. So, yeah.
Scrum teams, are they able to just
in version 1, well, in both versions, we allocate resources to a team. You can have 32 gigs or 48 gigs or 2 terabytes. That is your team resource. You can then come and ask us for more if you need it. So you want to keep it small enough so they're careful rather than just sort of spinning up apps and forgetting about them. But you want it large enough so they can experiment. In version 2, they have gone from a single user and password, which was shared, to user-based roles. So there are 3 roles, and these are the telling roles. There's a manager, there's a user, and there's an auditor role. So they have built this so that you could take the Cloudfoundry code, push it onto AWS, and start up your own private cloud, and start charging people for it by CPU, by network, by disk. So they do have a charging model baked in version 2 from the start. So yeah, they definitely are, and you can restrict how much resources they get. Did you have a...
Yeah, I haven't quite grasped what the management structure is of the Cloudfoundry stuff. What's the thing that's monitoring instances and doing that?
Okay, so there's 14 different components: cloud controller, routers, health manager, which is the one that the one that will answer your question. The DAs, I think they're called runners now, which does the staging and actually runs the droplets. The health manager, and it actually uses etcd as its underlying key value store. We'll actually check to make sure all instances are doing what they should and that there are the correct number of instances running at any one point in time. So that's what looks after that sort of monitoring of it. There's also another piece which is the CF metrics, which just pumps out all this data, which at the moment doesn't go anywhere. They haven't quite finished it. They may have finished it by now, but you can certainly use that. So one for the health manager and one for the back-end PostgreSDB. The major thing that you're going to be running is the DAs, the runners, so the droplet execution applications. I always think of the Drug Enforcement Agency. I can never remember what the DA stands for. You'll run the most of those. So far, and I don't know off the top of my head sort of the how many we're running, but we've had no problems with the health manager looking after the number of DAs that we've got. There's a question at the back.
What approach do you take to applications that aren't part of Cloudfoundry? So if you run it in queue, do you turn that into Cloudfoundry services, or still use Bosch, all of them Bosch, or just treat them completely differently?
Both, all 3, I guess. So there are 2 things that you can do. You can spin up these services with Bosch. You can just plug it into the manifest and it'll automatically spin up a Redis for you or a RabbitMQ or whatever it is. Alternatively, if you want some high availability components like RabbitMQ across 2 data centers in a federated mode, then what you can provide is a service broker which knows how to talk to your cluster of RabbitMQ, perhaps running on VMs, perhaps running on bare metal, and will automatically provision a username and password and give you a federated queue and pass that back to Cloudfoundry. So you can do it both ways. And it depends on the usage. Obviously, we want it high available and DR. We try to go for that wherever we can. But sometimes people literally just want to store session information in Redis, and if it goes away, they don't care. Sort of thing. Oh, sorry?
So basically, Cloudfoundry implement a well balance of service in front of the application.
Yes.
Can you explain how does that implement?
No. So it's got a router in front of it, which will, so it knows through the health manager how many instances are running at any one point in time and what URLs they're mapped to. So www.sky.com is mapped to these instances running on these different machines or running on these different DEAs, and it will load balance between them. Does that make sense?
But do you know the underlying component that you're using to run the load balancing?
No, I don't. I'm sorry. Sorry? No, that's part of Cloudfoundry. It's the internal URLs, which we did. So it says if it's this domain, only route it from internally. Yes?
So you bought Cloudfoundry for version 1.
Yes.
Maintained your own port. For version 2, it sounds like it's trying to upstream check it frequently.
Indeed.
Are you pushing stuff back upstream to the...
We are trying. We've got some merge requests outstanding, or some pull requests outstanding. We want to give back as much as we can. We want open source, write documentation, do all that sort of good stuff, and give back to the community. As I said, Cloudfoundry has a different view on what they want to do with the cloud. So they want you to be able to spin up a private cloud and start charging people for it, or do whatever it is. Our goals are a little bit different as a corporate entity. There are some features which we really want, and some features that Cloudfoundry wants and we want, but we're going to implement them differently because we can protect things behind a firewall where Cloudfoundry can't. So an example is, one of the things that people want to be able to do from our Scrum teams is, let's say you've got 6 instances and you want to be able to make sure that all those 6 instances are behaving as they should. You want to be able to type into the URL, go to the first one, the second one, the third one, the fourth one, the fifth one, the sixth one. So what we did is we have a special URL and a special internal URL where you can actually go to each one of those 6. Unfortunately, in the internet land and for Cloudfoundry, if you were to release that, that means that people could target one particular instance. So Cloudfoundry, what they want to do, I don't know how this is progressing. Each of these instances have a GUID. You would need to set that header in the browser, and then you'd automatically go to that instance. From their perspective, that is a nice solution because they obviously want to keep it private. However, from our perspective, we just want something quick and easy that we can do because they've got it in V1. We're sort of playing catch up in V2. Yes?
Have you measured, I have a couple of questions. Have you measured the efficiency of having this model rather than having a traditional VM model? That's one. And the other one is, do you miss some flexibility functionality from the older model using Cloudfoundry?
The first question, have we measured it?
Efficiency, like how much would it cost you to do the same thing you do right now using VMs, traditional applications?
Okay, so for a single web page, we need to have 48 VMs in prod and stage. 48? Yes. 12 in... Sorry, we'd need 24 VMs. That's exactly how. And that comes with, and we have default build profiles. So you need to run an OS. You need to give it probably a couple of gigs of RAM. We're going to run a web server in front of that. Maybe we could squeeze it down. Versus you could run 8 instances, each with 256 megs of RAM, which is 2 gig, versus having 12 or 24 times 2 gig VMs. We have saved a lot of space by running it through Cloudfoundry. We are out of space in the VMware field, but yet we can still run a lot more apps in the Cloudfoundry instances. And there was a second part?
If you miss any feature that is more of a compared to Cloudfoundry, is there any restriction, any cons that you see rather than using a VM?
Yeah, there's stuff you can't do. There are actual things that you can't deploy onto Cloudfoundry. So we've still got the VMware layer. We can still spin up VMs, and we know some teams will still need VMs, and that's fine with us, but we want the majority to go to the cloud. We just need to look at, the 3% of the remaining people who need the VMs. We can look after them, and then the cloud does everybody else.
All right, I'm going to stop us there. But thank you very much, Julian.
You're welcome. Thank you.